Okay, so let's start with the single phase induction motor. Okay, so in the last lecture we have seen the transformer, then two auto transformer, right? We have seen the working and application of all that types of transformer. So here we will go one step further and we will see how the motor works, right? So here single phase induction motor, also known as AC motor. Okay. So let us understood how it. So this is basically the construction of the single phase induction motor, right? You can see here there are two types of winding. Okay. One is this winding, this one, right? So this winding is known as a starter winding, right? Single phase starter winding. You can see here. Why I am using always single phase? Because in the power supply we will give the single phase AC supply, right? Because the construction of three phase supply is entirely different from the single phase supply. Okay, so we are studying the single phase induction motor, so that is why you will see everywhere single phase. Okay, so you can see one winding is winded to this pole, and again it is uses here also, and then it is completed, right? So what will happen if I will give the supply through this point? I will get the current will start from flowing here and will come back from here, come back to here, right? Okay, so these two will get so these two will get the supply from single phase AC supply, right? Okay, now in the center you can see there is a one which is known as a squirrel cage rotor, right? Now what do you mean by rotor? Okay, it is also have a winding, right? In that squirrel cage there is a small winding, there is many winding in that squirrel cage rotor. So basically we have two winding, right? One is a single phase starter winding, this one, and second one is this rotor winding, right? So this one, what we can say this, we have two winding, one is a starter winding and second one is the rotor winding. Okay, and in the between that rotor we can see the shaft, right? Here you can see the shaft. So what do you mean by shaft? Shaft is that main point which is rotating. Okay, shaft is basically the rod which is moving, which get rotated, right? And whatever you want to rotate, we will install that wheel on that shaft. Fine. So this is the construction of the single phase induction motor. Let us see how it works. Okay. So basically it has a very long working, but it's very simple. We'll understood one by one. Okay. So let's start. What will happen when we will on the AC supply? Current will start flowing here, right? Current will start flowing here. So because of that current, flux will get generated, right? Flux will get generated. Okay. Now that flux we will say that is starter flux, right? Because it is producing because of the starter, right? So that is a starter flux. So once again, what will happen when we will give the supply here? We will the flux will get generated, and that flux is known as the starter flux, right? Now, but let's see what happened. Don't you think that flux will also link to this rotor, right? Because rotor is placed nearby starter winding, and when the flux will generated, that flux will link or will cut that rotor also, right? So according to Faraday's second law, we all know that according to Faraday's law, we all know that when conductor cuts the flux, EMF is induced in that conductor, right? So don't you think that in the rotor we will get some induced voltage, right? And because of that induced voltage, current will also get flow in that rotor. Right? So it is little bit confusing. I am telling you. I will explain you once again. First we will give the supply. Because of that supply, current is flowing in that starter winding, right? And when the current will flow in the starter winding, it will generate flux. That flux is the starter flux, right? But that flux will link to the rotor because rotor is placed nearby to the starter. So because of that flux linkage, EMF get induced in that rotor according to Faraday's law, right? And when the flux will link in that rotor, current will get flow in that rotor because rotor is the closed path. Therefore, the current will flow in that rotor. And because of that, rotor will generate its own flux, which is known as rotor flux. Okay, so here we have two flux. One is a starter flux, and because of the starter flux, right, there is many processes going on, right, and we get rotor flux also. So there are two flux, starter flux and rotor flux. Now what will happen when these two flux will interact with each other, right, will touch each other, torque is produced, right, and because of that torque, that rotor will start moving. What do you mean by torque? Torque is nothing but kind of force, right, the force which is required to move anything in the rotation, right. So because of that torque, what will happen? The rotor will start moving. Okay, and this is the simple working of single phase induction motor. Okay, so what we will do, we will read once again, then you will get clearly understood. When a single phase AC supply is given to the starter winding, the alternating current starts flowing through the starter or main winding. So we can say that it is a main winding, this one. Okay, so when single phase AC supply is given to the starter winding, AC current starts flowing through the starter. This AC, that is alternating current, produce an alternating flux. So I told you, right? And that flux is called as a main flux. You can say main flux or a starter flux, whatever you want. This main flux also links with the rotor conductor and hence cuts the rotor conductor. Okay, so it will cut the rotor conductor. According to Faraday's law, electromagnetic induction, EMF get induced in the rotor, right? As the rotor circuit is closed, the current starts flowing in the rotor, and this current is called as a rotor current, right? So the current which is flowing in the rotor is known as a rotor current. And because of that rotor current, it will produce its own flux, which is a rotor flux, right? So we have a two flux, right? Starter flux, that is a main flux, and a rotor flux. Now there are two flux. One is a main flux and other one is a rotor flux. These two flux interacts with each other to produce the desired torque, which is required by the motor to rotate, right? Here motor means rotor, right? Because moving part is a rotor. Since this flux is produced due to the induction principle, right? So the motor work on this principle got its name induction motor. So someone ask you why it is known as induction motor, right? So we can say that because of the principle of induction, EMF get induced in the rotor, right? And after that, what happened? Rotor produces its own flux and start moving, right? When the two flux interacts with each other. So that is why it is known as an induction motor, right? Because EMF is inducing, right, in the rotor flux, in the rotor. So this is a working of a single phase induction motor. Okay, so here also we need Faraday's law. So I will recommend you that before starting this topic, just go through Faraday's law, right, and understood it, right. So and to understood you can go to the chapter number 1. There it is clearly mentioned how it working, what is the working of the Faraday's law. Fine. Now what are the different types of single phase induction motors? Okay, so there is a split phase induction motor. Okay, split phase means that after one time there are two windings. One is a main winding and one is a rotating winding. Okay, right. In the main winding there are two types of winding. One is a rotating winding, and one is a main winding. So that two windings get separated by a centrifugal switch after few times. So that is why it is not a split phase induction motor, right? Because that phase gets split. Capacitor start induction motor, right? So we use a capacitor. Capacitor start, capacitor run induction motor. right? So this type of motor we are using in the fan also, right? In our home we have that fan, ceiling fan we use. Okay, this capacitor start, capacitor run is also known as a permanent capacitor motor. Okay, so basically in our fan the motor belongs to permanent capacitor motor. Then we have a one more type, universal motor, right? So universal motor basically works on both AC also, DC both. They works on AC voltage also and DC voltage also, right? Because except that universal motor, all the motors which are mentioned here, they are basically works on AC only, right? But universal works on AC also and DC also. And the last one is the shaded pole induction motor. Okay. So these are the different types of single phase induction motors. Okay. So application. So basically motor. I don't need to tell you the application of the motor, right? You will see everywhere the function of motor, right? Everywhere, in fact, fans, refrigerators, air conditioners, okay, vacuum cleaners, washing machine, centrifugal pump, small farming application, right? For example, tube wells, right? In the tube wells we need motor to generate, to pump the water out, right, from the boring. Blowers, right? Blowers is used to ignite, right? It's used to blow, right? It means it used to give the wind. Right, so all these are the applications. You can add some more application also, right? For example, escalator, right? In the escalator, or you can write conveyor belt. Then you can add sewing machine. Sewing machine means, right? So all these are the application of the motors, okay, in the single phase induction motors. So with this our chapter gets completed. Okay, thank you very much.